Hello friends, we can see a new chapters known as carboxylic acid derivatives. In the carboxylic acid derivatives, we have to define what is meant by carboxylic acid derivative. Here, these are the organic compounds which are obtained from the carboxylic acids by certain chemical reaction. See, this is the carboxylic acids. In that carboxylic acids, we have to add reagents, and there is a formation of the carboxylic acid derivative. Therefore, these are the organic compounds which are obtained from the carboxylic acids by doing a certain reaction are known as carboxylic acid derivatives. These are simple definitions. The derivative means these are the obtained from the carboxylic acid. Here, name itself indicate the definition of the carboxylic acid derivative. These are the derivatives which are obtained from the carboxylic acid simply. Or in another way, these are the organic compounds which are obtained from the carboxylic acid by certain reactions. We can take different examples to understand the carboxylic acid derivative. See here, we can take a carboxylic acid R C double bond O OH. In that, here this is a carboxylic acid. In this carboxylic acid, we have to replace these OH groups by different reagents. Here we have to add here the chlorines. Here a replacement of OH groups by chlorines, and there is a formation of R C double bond O Cl. It is called as acid chloride. Acid. These are the derivative of the carboxylic acids. Then we can take another example also. Here we have to add here NH2 groups. Replace this OH group by NH2 groups. There is a formation of R C double bond O NH2. It is called as acid amide. Acid amide. This is again another carboxylic acid derivative. Here again we can also replace this by OR groups. OR. Again there is a replacement of this OH group by OR groups. R C double bond O O R. Can take R dash. It is called as ester. Again we have to replace this by different regions R dash C double bond O O. What is happens here? R C double bond O O C double bond O R dash. It is called as acid anhydride. Acid anhydride means from the carboxylic acids we have to obtain a different derivative: acid amide, acid chloride, ester, and acid anhydride. That's why all these are the derivative of the carboxylic acid. Here a different organic compound obtained by the replacement of OH group by different reagents to form a different carboxylic acid derivative. Therefore we can define again, these are the organic compounds which are obtained from the carboxylic acid by doing a different reactions or doing a certain reactions are called as carboxylic acid derivative. Again we can take one example. It is the acid chlorides. Here acid chloride, we know that it is another examples of the carboxylic acid derivative. Here it is also in general, it is also written as R C double bond O Cl, general formula of acid chlorides. Again here Cn H2n plus 1 COCl. It is a general representation of the acid chlorides. Here these are the acid chlorides. Here we can take the example of CS3COCl. We can take acetic acid CS3 C double bond O OH, and here we can obtain CS3 C double bond O Cl. Means here we have to replace this OH group by chlorine atoms. Means here plus Cl and minus OH. These are the carboxylic acid and these are the carboxylic acid derivative. It is called as acetyl chloride. It is called as acetyl chloride. It is a simple representation reactions to form the carboxylic acid derivative from the carboxylic acids. It's a simple reaction. We have to see how the actual prepare the different derivative of the carboxylic acids. We have to take another examples, the preparations of the carboxylic acid derivative. First preparations from the thionyl chlorides, that is the carboxylic acids. Here carboxylic acid is reacted with the thionyl chlorides. What happens here? In these reactions, the thionyl chlorides contain chlorine atoms. Here, the replacement of this minus HCl can take place. And here what happens again, this is the groups can be eliminated from the reactions, plus minus SO2. What happens here? CS3 C double bond O Cl. It is called as acetyl chloride. It is called as acetyl chlorides. Again here you have to write down here also HCl plus SO2. It is a simple reaction. The HCl is also removed and SO2 also removed, and there is a formation of the acetyl chloride. It is a simple reactions. The acetic acid reacted with the thionyl chlorides to form acetyl chlorides. The simple, it is a derivative of the carboxylic acid. Acetyl chloride is a derivative of the acetic acid. We can take another example also. From PCl5, that is the phosphorus pentachlorides, is reacted with the acetic acid. What happens here? See, a different derivative, different carboxylic acid derivative is obtained. Here, this is a Cl molecule is HCl molecule is eliminated here. HCl plus HCl. Again, what happens? Again here, what is this? POCl3. What is the remaining? CS3 C double bond O, and here is the Cl. There is a formation of again acetyl chloride. Again there is formation of the acetyl chlorides. Then we can take the different chemical reactions of the acetyl chlorides. Here, first reaction, chemical reactions of the acetyl chlorides is the hydrolysis reactions. In these hydrolysis reactions, we have to hydrolyze the acetyl chlorides. But what happens in the hydrolysis? Again, there is elimination of the HCl molecule can be take place. And what happens? There is a CS3 C double bond O, and here what is the remaining here? OH. That is the acetic acid. It is the chemical reactions of the acetyl chlorides. Then we can see the mechanism of these reactions. What happens in the mechanism? Here, the lone pair of electron of oxygen attack on the carbon of the acetyl chlorides. Again here there is a rearrangement of the reaction take place. Here CS3CO minus is there. Then here Cl, again O, hydrogen, this is the positive charge. What happens? This lone pair again come in the sides, and the chlorine is the good leaving group is eliminated, minus Cl. Here what happens? CS3 C double bond O, again here O, H, and here is the positive charge. Here what here with the chlorine here? They can abstract these protons. The chlorine abstract these protons, and here the lone pair of oxygen atom regains. Here what is the product? CS3, again C double bond O, here OH plus HCl. This is a simple mechanism of the hydrolysis of the acetyl chlorides. Here I am repeating once again. Here lone pair of oxygen atom attack on the carbon of the acetyl chlorides. There is a formation of the such type of rearrangements. Here we can use the lone pair of electron of the oxygen atom. That's why oxygen atom acquire the positive charge, and here due to formation of unstable compounds, they can be stabilized. Here lone pair of lone negative charge on the oxygen atom, they can transfer here. The chlorine is the good leaving group, it can be removed from the reaction mixture, and there is a formation of this type of compounds. Again, the chlorine which are removed here, they can abstract these protons, and here the positive charge which are present in the oxygen atom, which can regain its lone pairs, and there is a formation of these compounds. It is the acetic acid, or it is a carboxylic acid